All right, everybody. So now that we've established all of the ideas from the last lesson, which was really the idea of taking a function, making a table, and then putting the information from that table into a graph. What we are going to do today is we're going to do the opposite. We're going to start with our graph, and we're going to kind of work backwards from that and figure out what function fits the graph that is there. So we're going to have a few steps to help us out here. This is 1.7b notes. I know your sheet says A. You can change that if you want to. So we have B. If it does say B already, then I guess that's good. All right, here we go. So writing a rule from a graph. Step one, first thing we're going to do is we're going to change those graph points into the number forms. We're going to make a table for the graph. So we're going to, either a horizontal or a vertical table. We're going to make a table with those values. And what we're going to do next is we're going to find a relationship between the input and the output values. So this is that whole idea of figuring out how do we go from those inputs to those outputs. How are we going? What's happening to the numbers to make that happen? So as it says here, we're going to look at a few things. What is happening as you look at the y's? Are they going up or down by the same amount? If that's true, then this is the number that we multiply by. We're going to multiply x by that. If x is jumping, we're going to divide by that jumping amount, and that's going to make a fraction. So what we're going to do then is we are going to create another row in the table multiplying x, and then we're going to have to figure out what is adding or subtracting to actually get to the y. So after that, what we're going to do is we're going to write a y equals rule that describes what's happening. And lastly, make sure you check and make sure that you see and make sure that your rule works for a value towards the end of the table. All right, so let's see this play out in a few examples. All right. So, first thing we're going to do is we are going to look at the graph that we have. So we see a bunch of points, and what we're going to do is we're going to turn those points into our x and our y values. So our first point has the values 2, 0. Notice that we have that in the middle blank. I would leave that there. Then we have the point 4, 1. Then we have the point 6, 2. Then 8, 3. And finally, 10, 4. All right. So, the first thing that we need to look at is the fact that our x values are jumping by 2. And the way we can see that is, if we look at our x values, from 2 to 4, we're going 2. From 4 to 6, we're going 2. 6 to 8, we're going 2. 8 to 10, we're going 2. So x values jump by 2. It's also important for us to notice that our y values are all jumping by 1. What this is telling us, this information combined, is telling us what we have to multiply our x values by. The way we get the number that we're going to multiply the x values by is we take our y jump, and that becomes the numerator of a fraction, and we take our x jump, and that becomes the denominator of a fraction, and that's what we multiply x by. So we want this middle row to be 1/2 x. So also, that 1/2 is going to go out in front of the x in our rule down here. So we're going to end up with the values 1, 2, 3, 4, and 5 here. So that's everything involving the 1/2 x. Next, we're going to see how we go from that middle row to the bottom row. And we're looking for a single pattern here. And you'll notice that you go from 1 to 0, 2 to 1, 3 to 2, 4 to 3, and 5 to 4. Each time we're doing the exact same thing, which is -1. And that's what's going to finish up our rule then, -1. So our rule ends up being y equals 1/2 x minus 1. Let's check it with a value towards the end of the table. We'll use the points 10, 10, 4, and test it out. So my y value in that point is 4, and we're hoping that if I have 1/2 of 10 minus 1, that's going to give me 4. Well, 1/2 of 10 is 5, and 5 minus 1 is 4. So this worked out. We got the right rule. Nice work. All right, so next example. Here's our new function. We're going to make a rule, and then, we're going to make a rule through this process. First, we have to find our points and write down the coordinates. First point that we have for this particular example is 2, 6. Then we have 4, 7. Then 6, 8. 8, 9. And 10, 10. All right, we have our points written. We need to figure out what we're going to put here, how our x is changing. So let's start that process. We can see that our x values are jumping by 2. And we can see that our y values are jumping by 1. Remember that the 1 is going to become the numerator here, and the 2 is going to become the denominator here. So kind of like last time, we're multiplying x by 1/2. That goes in our rule as well. So we take 1/2 of the x values, and we get 1, 2, 3, 4, and 5. 1/2 of 2 is 1, 1/2 of 4 is 2, so on and so forth. Let's see what's happening now to get from that middle to the bottom. We need the same rule to happen for all of these, and you may notice that each time we're adding 5. 1 to get to 6 is plus 5, 2 to 7 plus 5, 3 plus 5 is 8, 4 plus 5 is 9, 5 plus 5 is 10. So we're adding 5 each time, and that goes into our rule then. Now we should use one of those later points to test again, make sure it's true. So I'll use the point 10, 10. Does 10, 10 follow this rule? Well, my y value, we see there, is 10. So the question is, does 10 equal 1/2 of 10 plus 5? Well, 1/2 of 10 is 5. 5 plus 5 is 10. So this one works as well. All right, 2 more examples. We're getting good at this by now, I bet. I hope it's starting to make a lot of sense. All right, again, start out writing out the x, y, and y values from the points. In this case, we have the point 1, 0. It's the first point there. We have 2, 3. We have 3, 6. 4, 9. And 5, 12. Let's look at the jumps. We can see that for x, the only jump that we have is jumping by 1. And for y, the jumps that we have are the number each time. The number each time is increasing by 3. So we can then imagine that this is going to become, in this box here, the fraction 3 over 1. 3 over 1 is just 3, though. So what we have going on is 3x. That's what's happening there. I'm going to put that 3 next to the x in the rule. Let's calculate this middle row then. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. Now let's look for that second pattern. Going from this middle row to the bottom, we can see that each of these numbers we're subtracting 3 from. And that finishes up the rule. -3. So 3x minus 3, we'll check using the last one as we're used to doing at this point. 5 12. So we put 12 in for y, and we want to know, does that equal 3 times 5 minus 3? Well, 3 times 5 is 15. 15 minus 3 is 12. So this one also works. We came up with the correct rule. All right, last example before you're in class practice. This table below shows temperatures in Celsius converted to Fahrenheit. This is useful if you travel abroad because most countries measure temperature in Celsius. It's true. The U.S. is one of the few that uses Fahrenheit. So knowing Celsius or knowing how to go between them can be really useful. So let's write a rule for that using what we've learned here. First, we need to find those jumps. That's our first goal. So let's see. Looks like the Celsius temperatures each time, well, up to that last one anyway, are going up by 1. Now, what that means is we're going to kind of ignore the 21 for the moment. We'll come back to it later. But to make our rule, we're just going to look at the first 4 because those ones have a constant jump. They're going up by 1 each time. And for those first 4, the y's are going up by a constant number 2. If you look at the distance between 50 and 51.8, that's an increase of 1.8. Add another 1.8, and you get 53.6. Add another 1.8, and you get 55.4. So for this, we're going up by 1.8 each time. And what that means is over here, we're going to have 1.8 over 1 times c, which means that we have 1.8 times c. So what we're going to have to, and remember, that is then part of our rule. If we want to use Fahrenheit temperatures, or find Fahrenheit temperatures, the first part of what we're going to have to do is take our Celsius temperature and multiply by 1.8, according to the rule that we have there. From there, let's put down what the new Celsius temperatures are after multiplying by 1.8. We get 18. That's 10 times 1.8. 11 times 1.8 is 19.8. 12 times 1.8 is 21.6. Next up, 23.4. Next up, 25.2. And we can do this to the 20. It's just going to be a little bit of a jump. 20 times 1.8 does give us 36. At this point, the next pattern should work for all of our numbers, even the 20. So let's see if it does. Is there a constant number that we're adding to the red numbers to get to our bottom numbers that are in Fahrenheit? And the answer, of course, is yes. We are adding a number each time, the same number. Each time we add 32. If you don't know that, what you can do is take the Fahrenheit number, subtract the red number, and you'll see that each time when you do that, you're going to get 32 as the answer. So we get plus 32 there then. And that is our rule. So we've seen a few examples now of how to use graphs and even just a table to come up with rules for patterns. So what I want you to do is try out some of these practice problems out of the textbook, get a little bit of practice, ask for help, and then you should be good to try the homework out. So thank you for watching, and I hope that you learned something here.